Hey Chem Kids, this is Campbell here. In today's video, we're going to talk about physical and chemical properties and physical and chemical changes. So what's the difference between a physical and chemical property? Well, a physical property is something that we can observe or measure without actually altering the identity of the substance. Color, right? This piece of aluminum here is silver. I don't have to do anything to figure out that. My brass here, right, we measured the density of this without altering it, right? We took its mass and we recorded its volume, and we could do that without actually doing anything to my sample of brass. Melting points and boiling points also are physical properties. Right? If I take a block of ice and I melt it, it's just going from solid water, H2O, to liquid water, H2O. Or if I boil it, right, it's just becoming water vapor. So those are things that, while they involve heat, don't change the actual identity of the substance itself. That's different for a chemical property. A chemical property is something that cannot be observed unless we actually alter the substance. A good example of that is flammability. I have my aluminum here, and I also have a bottle of ethanol, and I want to know, are these flammable? Well, the only way to figure that out is by lighting them on fire. Well, I'm going to put a little match here on my aluminum, and nothing's happening. Obviously, this is not flammable. If I take my ethanol here and I squirt it on the counter, woo! That is definitely flammable. So that's a chemical property because obviously I burned the ethanol and I got carbon dioxide and maybe some water. Let's talk about changes, physical and chemical changes. Well, obviously, if a physical property we can observe without altering the substance, then a physical change also doesn't alter the identity of the substance. So if I crush something, right, if I take a rock and I pound it, right, I just get a little rock. Or tearing, right, here's your chem test, and I imagine there are times where you're going to want to do this. Well, it's still paper. Might be harder to do your test, though. Melting is a physical change also, right? If I take, like I said, a block of ice and I melt it, I still have water just before it was solid, and now it's a liquid. So physical change, just like physical property, doesn't alter the substance that I have. That's, of course, different for chemical changes. Chemical changes do alter the identity. For example, rusting. This is actually the lock that's on my acid cabinet, which clearly needs to be replaced because it is quite rusted. In fact, I'm afraid that if I close it, I may never get it open again. Burning. Right? Another thing you may want to do to that chem test, besides tearing it, right, is lighting it on fire. Clearly, once this is burned, it's no longer your chem test. It's just ash, right? A bunch of carbon. Whoop. All right, so those were chemical changes. Just like chemical properties, in order to observe them, I actually have to change the chemical identity of the substance. My paper, which was cellulose, which is a bunch of carbons and hydrogens and oxygens, became carbon dioxide, some ash here, maybe some water somewhere. Let's quiz you now. Let's do some true or false. True or false? Density is a physical property. Well, to measure density, do I have to alter the substance? No. So if you said that this is true, you are correct. Question number 2. Flammability is a physical property. Well, if I light something on fire, does it change the identity of the substance, the chemical identity? If you said false, you are correct. Flammability is a chemical property. Melting ice cubes is a chemical change. If you said false, you're correct, right? I melt an ice cube, it's still water, it's just now liquid water. Rusting is a chemical change. If you said true, you are correct. When something rusts, it actually changes the chemical identity. It actually becomes an oxide of the iron or whatever it was made out of to begin with. What about dissolving sugar in water? Is that an example of a physical change, or is that a chemical change? Well, sugar's sweet, right? If you dissolve it in water, what does that do to the water? Does it change it from H2O? No. So if you said true, you are correct. Dissolving sugar in water is an example of a physical change because all I'm doing is taking solid sugar and breaking all the particles into little particles. How'd you do? See you in class.